Hello. This is a second in a series of lectures aimed to prepare students for their first computer science class. I'm not going to spend too much time going over the previous lecture because you guys could just go back and rewatch it. But some of the concepts that we covered our last lecture, we talked about what computers are, what a program is. We talked about some of those fundamental math kind of concepts like expressions and values. We talked about variables. We talked about what a variable is, different ways to think about it. Talked about how to assign a value to a variable using an assignment statement. And then we started talking a little bit about data types, different data types. For example, we have kind of general categories across programming languages. Like we have number data, we have character data, and we have Boolean data. And we have more complicated types than that too. And as far as within JavaScript, we have numbers, we have strings, which is like our character data type, and we also have Boolean data. And then there was that distinction that not many languages might split up, have more variations of data types. For example, Java doesn't use a data type called number, but they have int for integer, float, double for our numbers that have a decimal point, floating point in them, and things like that. And then we started talking a little bit about Boolean logic. So today we're going to talk about functions, scope, conditional statements, and if we have time to talk about problem-solving techniques in general. But before we do that, I want to do a little refresher going back to that idea of expressions. And I want to make sure we have some of these concepts down. It'll make life a lot easier in the future. So I want to kind of remind you guys about this idea of order of operations, precedence. So when we have expressions, which is a collection of literals, variables, and operators that can evaluate to a single value, they can be boiled down to a single value, we have to have some way of determining which of those operators are going to do work first, which of the operations are going to happen first. And this is stuff you guys have woven into your very being at this point with all the math classes you've taken. But just to be clear that we're not changing those rules at all, our programming languages that we use are going to rely on the same rules of precedence and order of operations. You're going to find that the things that our programming languages does with our arithmetic operations remain true to math's order of operations. But you'll find that some of the things added on top of math, like function calls and things like that, have their own level of precedence. So there's always a rule for determining what happens before another thing. And this fits into our idea that our computers are deterministic machines that do things in order, right? So let's take a look at this expression here. So this is just a basic arithmetic expression, 6 plus 5 times 3 divided by 3. And on the left over here, I've got our order of operations, probably a little bit blocked out by the camera. That's fine. Let's double check really quick. Okay, so it looks pretty good. So taking a look at this, we've got three operators here. We've got an addition operator, plus sign. We've got a multiplication. We've got a division here, right? So going down our order of operations, the first thing that we're going to see on this list is multiplication. But actually, multiplication and division are kind of in the same bracket. I don't want to say kind of. They are the same level of precedence. As well as addition and subtraction are the same level of precedence. So we would definitely do either the multiplication or division first before this addition right here, right? For sure, we would do either the multiplication or division. So there's always a rule for determining what has to happen first. So all operators have linked with them some rule about their associativity. So associativity determines which operation goes first if two of same precedence. So pretty much almost all of the arithmetic operators you're used to are going to be left associative. So what that means is, let me get this thing back up here. What that means is, between the multiplication and the division, it would be the multiplication that happens first because it's on the left. So multiplication and division are left associative. So we do that 5 times 3 first. That would be 15. So now we have 6 plus 15 divided by 3. Now in terms of our order of operations, the division would happen next. So 15 divided by 3 would be 5. Be 6 plus 5. And finally, there's only one operator left, the addition operator. So that would boil down to 11. So that's pretty good. That stuff should be pretty familiar to you. But we were just starting to talk about Boolean data and how we can have whole expressions that are non-numeric expressions, but still are a collection of literal values, collection of variables that boil down to a single value. So let's go back to our console. Let's see. Where did my mouse go? Well, let's go back to our console. Remember, I did that by opening a new tab in Chrome. You do Command-Shift-J, or you could right-click on the background and click Inspect, or you could also click F12. And this is our way to just type some JavaScript right into the browser. So ignore all this red stuff here. I'm not sure what's going here, but it's not important for what we're doing. So recall, we could just plug expressions in. 7 plus 5. Arithmetic expression will be evaluated. The most basic expression we could do is just a single value. Then we could do something like this. 7 less than sign 10. So notice we have an operator again. We have one of these symbols like a plus, a minus, divides, or something like that, where it performs some action and it depends on some inputs. We could think of this like a function. We could think of it like a function. So the inputs are on either side of our operator, but again, some output is produced. So in the case of 7 less than sign 10, we get a true. In the case of 7 greater than sign 10, we get a false. So we could do things like combining some of the ideas that we've talked about. How about we do let instead of var? So we're going to use let, and you can read up a little bit on it. Let's just stick with let for now on. So let's say, let's make a variable called num_bananas again, equal 10. So now if I take a look at the value that num_bananas has been assigned, it's 10. And anywhere where we've got a literal, we can use a variable name, as long as it stands for something, right? So I could do num_bananas greater than 10. And that's false, because if we do the substitution, num_bananas stands for 10. Is it true that 10 is greater than 10? No, that's false. So that's why that's given us the value false. Now, we've talked about, there's a couple of these relational operators, okay, and they always output a Boolean output. So let's talk about the relational operators really quick. Another word for these, comparison operators. So we might use relational, we might might use comparison. So we've got our arithmetic operators, arith op, got plus, minus, divides, multiply. If you want to do exponent, you could do two of those asterisks. And then here, let's talk about comparison. Comparison operators. So this is if we're comparing two values, and the output is always a Boolean, okay? Boolean. So we could do something like our less than, we could do something like greater than, you can do, let's see. So if you want to see if some value is smaller than another value, this would have to be numeric value. You could do less than. You could do, if you want to see if some value on the left is greater than the value on the right, you could do this angle bracket here. You can also do a less than or equals to. So let's see here, 7 less than or equal to 7 is true. You could also do greater than or equal to. So is it true that 9 is greater than or equal to 9? That is true. There's also another one. If you want to compare for equal value, you can use two equal signs. So be careful here, because when we think of equality, when we say something is the same, a lot of times we say, oh, age equals 6, like we're saying it's the same. So this double equal sign will output true or false if the values on either side are the same. Don't confuse this with the single equal sign, which is our assignment operator. We're basically saying with our assignment operator, this now stands for this, as opposed to the double equal sign, which is testing, are they the same? So if I do something like this, okay, let's say we have num bananas, right? So we could say num bananas double equals 15 would be false, because num bananas stands for 10. It's not true that num bananas is the same as 15. Let's try num bananas double equals 10. Well, that will give us true. Good. So now, what about num bananas equals sign 11? So it did not give us a Boolean output. And if I want to take a look at the value of num bananas now, it's 11. So guys, everyone makes this mistake. Try to get that in there. I still make this mistake sometimes, that if we want to compare two values, use two equal sign. If you want to assign a new value to a variable, single equal sign. So be careful about that. Okay, now these are our comparison operators, and these they can work on numbers. They especially work on numbers, but we could also compare two strings too. We could say, is it true that Bob is the same as Bob? That's true. How about Bob, is it the same as Bob with a capital B? Wow. Even that much is different. Because if you think about it to the computer, that capital B has a different character encoding. There's different ones and zeros there. Those are as different as night and day. So that's something to be aware of. So our double equal sign is another one of our comparison operators for comparing two different values. And they could be variables, whatever, it doesn't matter. Now, we also have some of these Boolean operators for combining Boolean values in different ways. Well, let's take a step back and let's kind of see how we can combine some of this stuff. So what if I had 7 less than 10, which is true, right? What if I compare this whole thing to false? Take a look at this one. Back. So we have some parentheses. Whatever's in the parentheses is going to be evaluated first. 7 less than 10, we do it over here. So 7 less than 10 double equals here, false. So 7 less than 10 evaluates to, well, 7 is less than 10, so this would be true. And now we're comparing true and false. Are they the same? No. So this would output false. And there's kind of a little notation when I'm trying to determine, when I've got like a big expression like this, I'm trying to evaluate it on paper. I like to do this kind of thing where I do 7 plus 5 and then greater than 4 equals false. So what I like to do is follow the order of precedence, but everywhere where I see an operator, I draw a little line down and I evaluate it. So now I have 12 greater than 4, double equals false. And then 12 greater than 4, well, that is, put another little arrow here, that's going to evaluate to true. And now I have true double equals false. Well, that is going to be false. They're not the same thing. So that's a little method I like to do, so I'm remembering that our operators are going to produce something, right? Just always remember, anytime we have one of these operators, you're going to produce something. And drawing that little arrow from the operator helps me remember that. Okay. So now there are some operators that work just on Boolean input values and produce Boolean output values. As I hinted at earlier, we have these Boolean operators. Let's see here. So we have not, and or. And let's talk about these for a second. Each of these is going to take some input Boolean values, and it's going to produce an output Boolean value. Okay, so not is a little bit different than and or. Not in JavaScript is represented as an exclamation point. So the difference between not and an or is that not takes in one input. So we would do something like exclamation point, here I'm going to put a little arrow here, Boolean value. Not is pretty simple. It just flips the switch. If we plug a true into not, we're going to get false. If we plug a false into not, we're going to get a true. So I'm going to illustrate that over here. So here I have false. The output of false is false. What if I do not and then false? It will give me true. How about not and then true? Will give me false. And this simply is, it's an inverter. It just inverts whatever our input value is. So not takes in one value, where and or take in two values. So and or are for combining multiple Booleans. But I want to introduce you guys to this idea of truth tables. So you guys might have remembered something like this. I might say, I've got a function, f of x equals x plus 1. Okay, and we've got a lot of different ways that we could kind of describe a function that takes in inputs does some work, produces an output. We've got a lot of ways to do it. We could describe it in this formula form. We could draw a graph. We could also make a table. So let's say I start making a table here where I have my input values x and I have my output values f of x over here. So now if I plug in 1, f of x is going to be 2. If I plug in 2, f of x is going to be 3, etc., right? Well, that's pretty neat, but it doesn't really suit our needs. It doesn't really tell the whole story of what is this function unless we include infinity values, right? Unless we include in our table infinity entries for every single possible input value. This table doesn't do this function justice. We could, of course, do something like, x must be an integer, between this value and this value. Then we could restrict the domain. Then we could make a table that would include all the values. But let's just say we can't really do that, right? The table does not tell the whole story because I'm always going to be missing. Well, what about 4? It's 5. Okay. Well, what about 7? It's 8. Well, what about 10 million whatever? So there's something, and the reason for this is because our input value it's numeric, it's continuous as far as we know. It could be anything, right? That's not true if our input value is Boolean. If you remember, our input value, Boolean variables or Boolean values can only be one of two possibilities, either true or false. That means that for any function that takes in an input, Boolean inputs, we can make a table that tells the entire story of how that function works. So let's talk about OR. The OR function, it's an operator, okay? So you're gonna see two Boolean values. So I'll do bool. And the way we represent this in JavaScript is with two of these things I call pipes, but they're shift and then the backslash key. Bool, pipes, bool. So, and how about I do this, just to kind of illustrate what that would look like over here. What if I did true or true? So the inputs are Booleans, the output is a Boolean also. So OR and both serve to join multiple Booleans. So what's the story with OR? What does OR do? Remember, our arithmetic operators, each one has like a job, like it does a specific operation where addition takes the quantity of one side, the other quantity, and combines the quantities, right? So what does OR do? We could tell the whole story in a truth table because we're dealing with Boolean values. So truth table is going to look like this. Some of you guys may have seen this before. Well, we've got a bool on either side. Let's call the first one A and the second one B, and then we can do A or B. So remember, A and B can only be true or false. So we could actually list out all of the possible input values. So we'll say false, 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 true, true, false, true, true. And so if I plug in two falses, I get a false. If I plug in false and true, I get true. If I plug in true and false, I get true. If I plug in true and true, I get true. The rule for OR is if either one of the inputs is true, if there's any trues in there, then the whole thing ends up outputting true. And it makes sense. You could say, if you want to leave the building, you can either exit through the west door or the east door. And either one of those will get you to the outcome of leaving the building. Either one of those will be fine, right? So why don't we also we could just be thinking, oh, this is fine, this is fine. So this is the truth table for OR, and I'd like for you to open up the console and play around with OR a little bit and see if you're getting the same results as I'm writing up for you. So we could do something like, let's say we're trying to get a specific age, okay? And let's say that we want to get, we don't want any teenagers, okay? Let's say that. So we could do something like age is less than 12, or age is greater than 18. So we could test the age, and we could say, well, we're gonna plug in some value for age, right? We're gonna have a variable called age. It'll have some value, but this little expression right here is only going to output true if our age is not a teenager, and that includes 13 through 18 inclusive. So this is one way that we could do it. Either this is true, or this one is true. If either one of these terms on either side is true, then the whole thing is true. So that's the story of OR. So let's look at the story of AND really quick. AND. Okay, so AND has a similar format. We're going to have a Boolean as input on the left side. It's an operator, so it's going to be in the middle. Then in JavaScript, if you want to represent AND, you use two ampersands. And then a Boolean on the right side. So let's look at the truth table for it. Again, we're just going to give a name A to the first input and B to the second input. And then we want to describe what is AND. The output would be A and B. Well, let's enumerate. Let's list through all of these possibilities again. So we could have false, 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 true, true, false, true, true. So the story for AND is both inputs have to be true in order for the whole thing to be true. So if we're going back to that idea of the doors, say we're in a meeting room and you want to leave the building, you have to go both through the meeting room door and the building door in order to exit the building. You can't do just one, right? You can't just leave the meeting room and leave the building. So the other simple rule for AND is if there's any falses, it's false, right? So let's see here. This would be false, this would be false, this would be false, and this would be true. The only one that's true is if they're both true. So let's say we want to do another one. Let's make another Boolean expression where we're using AND. Well, a really good example is if the username is correct and the password is correct, then we'll let them do something, right? So I'm just going to make a username and a password up. So let's say here, if username, let's pretend again that there's a variable called username. And if our username is the same thing as hairdo and our password, oops, is the same thing as meow. Now this whole expression here, look at this entire thing is one expression, and it will boil down to a single true or false value because the whole thing hinges. In fact, why don't we do this really quick as an example. So let's say I did let username equal hairdo and let password equal woof. let's evaluate username double equals hairdo and password double equals woof. All right, so remember, this whole thing hinges on this big and here. Ultimately, we're going to evaluate each of the sides, and then we can make a final decision about that and. So if we have any of those Boolean conjunction, Boolean combination operators, or and, the output is going to be what data type? It's going to be a Boolean, right? Just like our relational operators, the output is always Boolean for these. So in the end, we should have either true or false. So let's evaluate this. Now that we do have variables with actual values, we can evaluate this. All right, so we have parentheses. Let's evaluate from left to right. So we'll do this set of parentheses first, and then we'll do this one. This term first, and then this other one. So username double equals hairdo. Well, double equals is our comparison operator that returns true if the terms are the same and false if they're not the same. So since username does stand for hairdo, then this would be true. So now I have true and, whoa, that's a weird ampersand. Just take it for granted that's an ampersand. And then on the other hand, we have password double equals woof. So let's take a look at password double equals woof. Well, is password the same thing as woof? Whoops. I wanted to make this meow. This should have been meow. That's our correct password. But woof is the password that was inputted. All right, so if we check this now, does password equal meow? No, because password, if we substitute in password, it stands for woof. So this is the same thing as saying woof double equals meow. And if we do this, we could do this if we want to. If we do this, this is going to be false. So now we have true and false. And remember the rule for and is that the only way it's true is if both of them are true. So this would be false. And this could be a switch to, maybe let you into catnip garden or something like that. So it seems like some dog was trying to infiltrate Hairdo's special play zone or something like that. So anyway, that would be like an example of how we could use all this stuff. If you need, take a second, go back to that list of the operators, and just kind of think about what are the inputs for them, what are the outputs for them, and what's the rule for them. Each one of them has a rule: less than, greater than, less than or equal, and then our double equal sign, and then and or. Okay, so there's Boolean logic. Now let's take a second. Let's see how we're doing with time. Okay, good. We're doing good with time. Okay, so the next thing I want to talk about is one of my favorite topics. It's one of my favorite things to teach, actually. And so this is going to be one of the biggest ways that we can introduce abstraction into our solutions. And you remember, abstraction has to do with removing those details, those fine details, so we could deal with the bigger picture, right? So this topic is, as an example of that, remember the starship captain. You don't need to know how the engine actually works. You have a module that handles it. You have your engineer, and you could simply ask, "Is the engine okay?" And then the engineer can tell you yes or no, and then you could focus on the bigger problem there, right? So this topic is the topic of functions. And so functions have a lot of overlap with functions in math. We're always going to be talking about input and output. Always, always input and output. So before we go into functions in JavaScript, let's do a little bit of a review about functions in general. And remember, again, this is the core. When we're talking functions, we're talking input and output. And we're talking about giving a name to a series of instructions to produce an output. So that way in the future, you don't have to worry about all of the steps. But we'll talk about that. We'll talk about the hokey pokey in a second. But first, let's do a little bit of a refresher on functions in math. And this stuff, again, is not stuff that I'm going to be too critical about, but you should know this. This should be something that you're comfortable with. There we go. Okay, so got this general idea of a function, our math definition, how to implement functions in JavaScript. And we're going to do some examples of function implementations. And then we're going to talk about some good habits and some common mistakes also. So let's see here. Let's see what we can glean from this. So we already talked about functions are important for making our solutions modular, for abstracting complicated parts into manageable pieces. And a big thing is once you have a function created, you can reuse it. And remember, this is huge for us when we're trying to juggle all this different stuff. We want to make our solutions, the parts of our solutions, reusable. Let's see. So the basic idea for a function is I/O, input and output. So functions take in 0 or more inputs and produce an output. Functions in math always take in an input. But in programming, we could have functions that take in 0 inputs but produce some output. Actually, let me take a step back and I want to describe something to you first. So we use functions to process information, but we also use functions as a way to abstract out details. So let's talk about the hokey pokey. If you don't know, the hokey pokey is a popular dance that is played on playgrounds. Kids play it. You may have learned it when you were a kid. If you didn't miss that much. There's not much to it. I'm not going to do the hokey pokey for you. If you need to, you can go look up what the hokey pokey is if you've never seen it. But the hokey pokey generally has a couple steps. I'll do a quick demonstration. So left hand in, left hand out, left hand in, left hand out, left hand in, left hand out, and then you shake it all about. Then you do the hokey pokey, and then you do the same thing with your right hand. Then you do the same thing with your left hand. There's a lot of steps anyway. So we can use functions to abstract out a lot of those details. If you know the hokey pokey, if you know all of the steps, then I can just say, do the hokey pokey, just that little bit, just say, do the hokey pokey. And you'll know to do all of these steps. Left hand in, left hand out, left hand in, shake it all about, right hand in, do the hokey, blah, 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 blah. So, it's like 30-something steps, all with just one word. That's very powerful. There's another point, though, that's important here, and that's the fact that if no one ever told you what the hokey pokey is, in fact, that's probably what I should have started with. I should have been like, do the hokey pokey, and some of you guys would have been like, I don't know what you're talking about, right? If no one had ever defined the hokey pokey for you, and just said do the hokey pokey, you're going to have a lot of confusion. You're just going to say, I have no idea what you mean by that, right? I have no idea what the hokey pokey is. So that's a big part of functions. When we use functions in programming, there's two main steps. So the first step is to define the function. And all that you're saying, it's similar to a definition when we're assigning a value to a variable, but instead of saying that this name stands for this piece of information, we're saying this name stands for these steps and produces this output. So for example, we might define a function f of a and b equals a plus b. So that's the first step there. F of a and b is a plus b. Notice we haven't actually plugged in any actual values yet. We've just said, I have a function, it has two inputs. You can see in those parentheses, two inputs, and the output of the function is the first input plus the second input. So now we can plug in some constants or some literals. We could plug in 1 and 3, that would be 4, right? Or 7 and 5, 7 and negative 5 would be 2, right? Now this is trivial because what we could do, our function basically does what we could do in one step anyway, which is just add the two inputs, right? But imagine we had many intermediary steps, and we say f of a and b is a plus b divided by b to the power of a, all of this stuff. Then having the ability to define it and then just plug in the input values saves us a lot of work. It's the same as having the ship captain and just say, how's the engine? The input, the input is a request. Tell me about the engine, the status of engine. Status of engine. Then the output is good or bad, right? But all the steps in the middle could be a lot of stuff. So functions are reusable and predictable. So let's talk a little bit about how functions in programming and especially JavaScript and math are very similar. So do you remember the formula for calculating the area of a right triangle? So we have 1/2 base times height, where we're going to plug in our base, we're going to plug in our height. B and H, when we define the function, we're not actually plugging in our values yet. So this is really important. B and H just stand, they're placeholders for when we actually do plug in real values. That's something that's really confusing. Another thing that's interesting about this is notice that the formula has some variables in it, right? B and H. But also some parts of our formula might be constant, might never change. That 1 divided by 2 part is always 1 divided by 2. It doesn't need a variable because it's never going to change. That part is always constant. So that's something we're going to see a lot of too. So we can use this function with different inputs to calculate the area of any right triangle. So that's the reusable part. Once we have this formula down, once we have this function, we could calculate the area of any right triangle. We could be confident that if we plug the input values into here, it'll always give us the same output. That's the other thing that's great about functions that allows us to build off of them to make something bigger, that they are dependable. Once we make them and they're set, we don't have to worry about, is that one piece in there going to always work, or is it going to fail sometimes? That's the definition of a function, or part of the definition of a function, that if we give it the same inputs, it'll always give us the predictable output. It'll never change its mind about stuff. So here we are, we're plugging in different values for base and height, but our function is the same. So the name of our function in this case, we called it area. The name of the first input is B, the name of the second input is H, and this will give us the areas of 2 different right triangles. Now, functions don't always need 2 inputs. As I said, when we're programming, we might have functions when we define them that take in no inputs, and that's valid. Take a look also at, so you can look at the example double x, where it takes in 1 input named x. It doesn't always have to be x either. We have subtract 1, with the input named m. And then if you take a look at volume of rectangular prism, we have actually 3 inputs, and that's fine. Then functions don't always have to take in a numeric input also. So going back to programming, we might have Boolean values as input, or string values, or any other kind, because we're going to learn there's some pretty weird data types out there. In fact, when you get to higher levels of programming, you could create your own data types. So take a look at this function. It takes in one input called likes Miles Davis bool, and if you plug in true, you get you're a cool cat, and if you plug in false, you get what a square. So notice that the output for this one was not even a Boolean. It was actually a string. So we plugged in a Boolean and we got a string or character data. This is not the syntax in JavaScript. So if you're thinking about running in there and trying to do it, this is not the correct syntax. I'm going to show you in 1 second. So let's just talk really quickly about the math definition of a function. And this is something that you've learned a long time ago, but it's good to know. So a function is a mapping between 2 sets of values. A mapping describes a relationship between 2 sets. So for this particular value in the first set, you might say this value in the first set is associated with this value in the second set. This value in the first set is associated with this other value in the second set. So let's take a look at this function double x, and the output is going to be 2 times x. Okay, so the name of the function is double, it takes in one input called x, and the output is 2x. Here are our 2 different sets of values, and you can see that this function describes the relationship between these 2 sets. And so the name of this first set on the left, by the way, is called the domain, and a lot of the time we're talking about what are the valid input values. And then the set on the right is called the codomain, and then there's a closely related term called range. I don't want to get into that right now, but if you're curious, this is something that's very interesting. Look up what's the difference between codomain and range. Okay, so going back to the definition, math definition of functions, something that's very important or critical to making sure that something is a function or it isn't a function is if we plug in some specific input value, we will predictably get the same output value. I don't know if you remember let's see if I have it. Here it is. The vertical line test. So if you look at the going left and right, that would be like our input value. And then the output is how high our load is, like our y value, right? So for the first one, no matter where we are on the input value, there's only one possible output value. So if we cross a vertical line through the graph of our function and it ever crosses 2 points, that means for one input, we have 2 different outputs. That is not a function. So that's why this first one passes the vertical line test. It is a function, and the second 2 are not functions. So this idea here, this is the math definition. We're going to have some differences with the way that we do it when we're programming. But most of the time, a lot of the time, our functions are going to follow these rules. Again, this really empowers us. It allows us to depend on one of these little modules that we made so that we can use it as something, in a broader scope, that we could use it as a module in a bigger picture, or we could reuse it in different places and not worry about is it going to work the same way. A classic example of something that's not a function is if you give me the input, can I borrow $1? My reaction to you will not be predictable. It might be the case that I got my payday, I'm in a good mood, the sun is shining, I had a good bike ride, and I'll be like, sure, you can borrow it. Here's $100, pay me whenever, right? Say you come to me on another day and I'm not feeling as great, The input is the same, can I borrow $1, but the output might not be the same. So you notice that this would not be a function, right? This would not be, we couldn't predict the output from the input, so therefore we just have to say no, right? Or not that we can predict, but that it'll always be the same output for some specific input. So let's think about the domain and the codomain for this function. So we have this function called square. It takes in one input called c. And we could say for all integers of c greater than -3 and less than 3. Take a look at this. Is this still a function? This is kind of interesting. So if our function is squaring the input, then if our input is -2, we have an output 4. And if our input is 2, we also have an output 4. Is it still a function? Well, the answer is yes. It's okay if 2 of our inputs go to the same output. That's fine. As long as every time I plug in -2, I always get 4, I can predict it, I can feel confident about it, right? But if we ever have a situation where I plug in -2 and one time I get 0, one time I get 4, that's where we have a problem. So this is still a function. Okay, so now let's get to how to define functions in JavaScript. And I'd like to actually begin using JS Fiddle at this point, because we're going to be doing stuff on multiple lines. The console is nice if we're dinking around one line at a time, but once we want to start to create multiple line things, let's use JS Fiddle. So I'm going to open up a browser. Oops, that was a browser. I'm going to take us to JS Fiddle here. Oh, I forgot to mention, if we're talking about the order of operations for and or, this little bit right here establishes that and happens before or. If you take a look at this, it will prove that. I'll let you do that on your own time. I wish I had remembered that. All right, well, the show must go on. So here I went to the address jsfiddle.net, and I see this thing here. Now, we're mostly going to be typing in this window here where it says JavaScript. And here's another thing. If you want to save some space, you can close this thing right here. So let's start out. I'm going to do something that we're familiar with. What if I did 7 plus 5 again, and I run it? Well, I don't see anything. Well, let's pop open the console. I'm going to hit Command-Shift-J. Ooh, it's clearing the console each time. Let's see if we can turn that off. We might have to do this as well. Clear console on run. Okay. Command-Shift-J. Okay. So, well, I didn't want to get into this quite yet. Okay, let's stay in the console for now. Then we'll go to JS Fiddle. So I'll talk about JS Fiddle in 1 second. So let's talk about implementing functions. Again, there's 2 main parts. And I really want to emphasize this because people get mixed up here a lot. There's 2 main steps if you want to make your own function. The first step is to define your function. Okay? 2 steps. If you want to make own function. 1. Define the function. 2. You can call the function. And that means to use function, plugging in plugging in real values as input. So define the function, then call the function. And it makes sense because if I just told you I've got a function called the hokey pokey, the input is the number of times you want to do it, and the function is do all these steps, right? If I told you that, then it would make sense if I said, do the hokey pokey, I'm plugging in the number 2. That means to do it 2 times, right? How about if the order was reversed and you didn't know anything about the hokey pokey and I just said hokey pokey 2? You would have no idea what that meant. You wouldn't know what the steps are. You wouldn't even know what to do with that 2, right? So it's important for us to define the function first and then call the function second. So let's see, I want to do it like this. No. Don't worry about this stuff. I want to look at the alternative. Okay. So in order to define a function in JavaScript, you use the keyword function. This always stays the same. Then you have, I'm going to plug in brackets here, function name, then parentheses. You will actually need parentheses here, and then input names. And these will be separated by commas. Input. As many inputs as you need. Then some curly brackets. So a left curly bracket, and that'll be, if you look by your backspace key, should be on the same row, like above your enter key. You hit shift and you press the square bracket key. Some people call these mustache brackets. I like that too, but I got used to calling them curly brackets. So you'll need a curly bracket to begin the function, and then a curly bracket to end the function. And then somewhere in here, the word return. And that means output. So here we have input, and here we have output. That was a lot. I'm going to do a couple examples for you to see. So why don't we start? I want to make a function that does something trivial just for us to get used to the syntax for how to make a function, how to define a function in JavaScript. So I'm going to use the keyword function. We're going to make a function that just adds 1 to whatever we plug into. So whatever value we plug into the function. So the name of it, I'm just going to call it add1. Then I have some parentheses. So anytime you see parentheses, you should be thinking input. That's where our inputs go. Just remember that. So function add1, and then let's plug in, let's give a name to our input. So I'll say num1. How about just num? Oh, that's a terrible name. I'll call it input num. Now, I don't want to hit enter because it's going to think, the console is going to think that I'm submitting this, but really it has to be submitted as one package. So I'm going to hold shift and press enter. I'm going to get my left curly bracket. I'm continuing to hold shift this entire time. And my right curly bracket. Okay. Now, final step here. So I'm going to use the keyword return. And here I could put in the expression, what do I want the output to be? Well, I just want it to be whatever I plugged in for input num plus 1. If I hit enter, it should say undefined. Okay. Now remember, there's 2 steps when we're using our own functions that we create. One of them is to define the function. That's what I did right there. We didn't actually plug in a real value for what we want to add 1 to. All we did is we said, I've got this function called add1, It takes in how many inputs? Well, I'm looking at the parentheses. It's only one input called input num. And when it finishes running, it's going to output whatever we plugged in for input num and add 1 to it. So let's look at the second step. So first we define the function. The second step is we call the function. So let's do this. I'm going to call the function by just using the name of the function, add 1. Now I got some parentheses here. Notice there's no keyword for add 1 or anything. There's no keyword there. I'm going to plug in a real value that I want to use as the input of my function. So let's say if I plug in 7, it gives me 8. What happened here? Well, we called the add1 function, and then your computer is going to say, I don't know what add1 is. I'm looking around. Oh, you defined it. You defined it earlier. Okay. So add1 takes in one input, and it returns that input plus 1. So this is really important. Again, we cannot use the function unless we explain what the function is. Or in other words, we can't call the function unless we define the function. Let's do another one. So let's see. I'm going to create a function. Let's say it's used for some purpose when I'm installing a pool or something like that. I'm going to call it the blurpler. So function blurpler. And this is going to take in, volume of the pool and then the height of the pool. Now notice we can call our inputs whatever we want, but something we definitely don't want to do is to actually start plugging real values that we want to use. Like literal values should never be used here. You should think of these almost like variables. Should never be literals. Otherwise, our functions wouldn't be reusable. The whole purpose of this is to take this solution and be able to apply it to different places. So we've got volume, we've got height. Now I want to show you something a little bit different here. I don't know what blurpler does. I wish I could have come up with a better example, but don't worry about it. The idea is that it's doing some work for something that's very valuable to us. But I want to show you something interesting. Within our functions, we could have variables that exist only in those functions. And that's important so we don't get values mixed up. So I'm going to do this. I'm going to do let temp equal 4. Then I'm going to say return volume times height plus temp. Oops. I don't know where that came from. Okay, auto-completed that. Temp. No. Maybe it doesn't like that one. Alright, let's try a different name for this because it's auto-completing. Temp A equals 4. So I declared what's called a local variable. That means it only exists within a specific area. This one temp A can only be seen within the function blurpler. It can't be seen outside of it. So let's say let temp A equals 4, and then we'll return. Oops. Return volume times height plus temp A. Okay, so let's do pretty trivial. We define the function. I want you to try to call this function using let's say 2 and 10. So 2 is the volume, 10 is the height. And let's see if it works as you expected. So pause it right here, see if you can do it. If you just do it in your head, that's fine, but make sure you can do it. So now if I wanted to call the function, I would just use the name of the function, blurpler, So I'm going to substitute in 2 for volume. I'm going to substitute in 10 for height. And the output would be 2 times 10 plus 4. And again, this is reusable. So I got blur. I could plug in 1 for the volume. I could plug in 40 for the height. And it gives me this value. So something to take note of here is both when we're defining the function using the keyword function and when we're calling the function, whenever you see parentheses, that's where your inputs are going to go. And each of these are separated by commas. So if you have more than one inputs, either in the definition or when you're calling it, you're going to separate with commas. Okay, so let's see how much time we have. Okay, we're doing really good on time. I want to talk about scope. Well, first, let's talk about input and output. So we talked about functions, and functions are going to be like these modules, basically, where we've given a name to a series of steps that produces some output. Now, we might have a lot of steps that happen in the middle that we don't actually see. And you remember, we have to be really specific when we're giving instructions to the computer. Unless we actually specify that we want to see the values that we're working with, the computer is just going to do them internally. We're never going to see it. So within JavaScript, I'd like to introduce you to a couple really important built-in functions. So blur and add1, we define those. Those are created. But a lot of languages, they actually come with some functions and different, constants that just come with the package of the language. So the first function I'd like to introduce you to is called alert. Now, alert, I could just type in alert with some parentheses and plug in a value in here. Let's do hello world. I'm not sure if you can see that, but it made a pop-up box. I made a dialog box pop up with that text in there. So this is an example of one of the functions for seeing some output. So in case we want to actually produce the output so we could see it. The one I want you guys to use more often when we're testing to see what the value of a variable is or what the output of a function is not alert. Because imagine we're testing a bunch of things, we're going to have all of these boxes to click through. It's going to get annoying really fast. So I'd like for you guys to use console.log. Now, console.log takes in one input, but the type can be a lot of different types. So if I console.log hello world again, notice this line, it just printed out hello world. Okay, how about, do I still have num bananas here? Let's see, num bananas. Okay, so I still have num bananas, it stands for 12. So what if I console.log num bananas? Well, output 11. So if we want to actually produce it in a way that we could see it in the console, use console.log, and we could plug whatever we want in between the curly brackets. As you'll see, there aren't many rules for what can be plugged into other things. That's kind of one of the things that makes programming so flexible, is that we can, use different values as inputs to other values. In fact, I'm a big fan of using function calls as inputs to other functions. So the innermost function will run, produce an output, and it'll go as the input to the next function, almost like a conveyor belt or each machine is doing part of the work and then handing it off to the next machine. That's called function composition. You've done some function composition in your math classes, but we'll do a lot of that in your programming classes too. But we'll get to that when we get to it. So I really want you guys to know console.log. It's going to be your main, almost like a bread and butter tool for us to see the output, especially when we're learning programming, or especially when we're debugging some of our programs that we can't figure out what's wrong with it. You're going to use console.log a lot to say, well, what was the value of the variable at this moment, or something like that. So that's how to produce output. We could do something like console.log and then plug in blurpler. Now blurpler needs its own parentheses too. And you see that the console is giving you a hint that takes in 2 inputs. But if you forget, look up at the definition. So console.log needs 1 input. Blurpler, whoops. We're going to plug in some real values for the volume and the height. So 4, 10. And it'll output 44. Okay, what happened right there? I want to run through it really quick. Give me 1 second. Okay. So I did function blurpler. That's not a capital F. So function blurpler, our parentheses for our input. So I have a volume and then a height. Volume, height. Hope I got that order correct. Got my curly brackets. I have let temp A equals 4, and then I'm going to return, our output is going to be volume times height plus temp A. So there is the definition of blurpler. Okay, so what happens if we do console.log blurpler for 10? Well, we would work from the inside to the outside. But you could just think conceptually that whatever we're plugging into console.log, all console.log is doing is just showing it on the screen. So it doesn't just happen internally, right? But if you want to work through it, let's work through it real quick. So I'm calling blurpler. I'm going into the innermost parentheses. So I'm calling blurpler. I want to use blurpler using 4 and 10 as the input values, the arguments. So then, first things first, blurpler is going to run, and it's going to produce some output value. So it'd be 4 times 10, 40 plus 4 would be 44. So then we can imagine that this is finished running, and what we're actually doing is just console.log with 44 in there. And so that's just going to produce on the screen 44. So anytime that we, So anytime that we're calling a function, this whole process happens again. It looks for the definition of the function. It takes the input values, so we had here 4 and 10, and substitutes them in. And remember that the order we plug them in determines which one is where it's going to be substituted in the inputs. Okay. Another point I wanted to make is I want you to be clear on some of the terms that we're going to use a lot of the time. when you define a function, so these are two terms that have to do with input, okay? And the two terms are parameter and argument. They're easy to get mixed up. Parameter has to do with the definition. Argument has to do with the function call. The parameter is going to be, so our parameters in this case would be volume and height. The arguments would be 4 and 10. So if I ask what arguments were used, I'm talking about in the function call, what were the actual values that were plugged in? Whereas parameter has to do when we're defining the function, what were the names of the placeholders of those inputs? Volume, height. So that's going to be very important. Okay. So okay, yeah, let's go on to JS Fiddle now that we have done a lot of this. Oh, right. One last thing, and then we can go to JS Fiddle. So we talked about how to produce output on the screen, or actually in the console. You use console.log, right? Now, something that a lot of you guys have probably been waiting for is the ability to get user input. So we have a lot of values that are written in. Like if I do something, let temp b equal 40, that would actually have to be in the instructions I typed in, right? But what about getting information when the program is running from the user? Not in the code, but from the user, whoever's using it. So there are a variety of ways to do that, but for the sake of simplicity, we can use prompt. So prompt is another built-in function that comes with JavaScript. And prompt is, the usage for prompt is a little interesting. So prompt takes in one input, okay? The whole point of it is to get some information from the outside world, from the user. Prompt takes in one input, and if you think about the word prompt, it's like to ask someone. I prompted this person to do this thing, right? So the input for prompt is going to be the message you want to display when the user types something. So I might do something like enter your name. So it'll make a pop-up box pop up, and notice that input is just the message that I displayed above this text box here. So now I can type in whatever I want. In this case, I'm going to put in my name, Brian. Now remember, functions take an input, produce output. The output of prompt is whatever the user typed in. So, how can we use this effectively? We only need to use this if we need to gather information from the outside world. So I don't want you guys to go overboard on this. If there's a reason to use it, we should use it. And it is pretty fun to do. But a lot of the work that happens is not going to be constantly, getting information from the outside world. But let's see, how can we use this in practice? So let's say we wanted to store the username in a variable so we could do stuff with it later, like compare it to hairdo or something like that. Well, we could do something like let uname. That would be declaring a variable, right? That would be like saying, I want to create a new variable called uname. And I could set a value to it and just say, let it be hairdo, right? But what if I want to get user input and store that? Well, we would run prompt. And prompt takes in an input. We could say enter username. So what happens here, first, prompt would run. The pop-up box would pop up. User would type in whatever they wanted, and then prompt would spit out a value, and that would be used. Let's say we typed in woofers. It's kind of like we did that. So let's try it out. So we're going to do prompt, enter username. We're going to get a pop-up box. I'm going to type in woofers. Okay, now let's see what uname stands for now. So the variable uname is woofers. So we talked about how to produce output on the screen. This would be one of your ways to get user input from the outside world, bring it into your program somehow to do something. I do want to note something. A lot of the time we want to get numbers. Prompt is going to always output the string data type. It's always going to be string data type. So that might cause some issues in the future. If you want to force it, if you want to force prompt to, or if you want to actually take a string of digits, like 77, and you want to convert it to a number, there's another function called parse int. Let's see here. And that'll give me the number 77. In fact, why don't we check it? So I'm going to do type of the string 77. So what type is this thing? It's string. Let's see, what's the type if I just have 77? It tells me it's number. Now what happens if I do type of parse int and I plug in a string of digits? So this is still a string, right? But we're converting it using parse int. I get number. There's also a parse float. If you want to pull out a string of digits that has a decimal point in it. So let's say 0.5. So it'll give me the number 0.5. If I did parse int, let's see, I'm curious, and I did 0.5. Remember, I mean, an integer is a whole number. I'm not going to do type of, though. Let's just see what parse int gives me. So it rounded down because we can't have any decimal in our integer. And it's trying to pull out, to parse out, make sense of, and pull out an integer value from the input, which is a string of digits, but it's got a decimal point. Okay, so I would highly recommend take a breather at this moment. Play around, make some functions. I want you to define some functions. See if you could make something to calculate the area of a rectangle, and then reuse it. Try different values, make sure it works. See if you could make something to calculate the tax, maybe a tax calculator for if you're taking your significant other or your pet to the restaurant and you don't want to look like a cheapskate like me. So try making some functions, that you could reuse, and then you could build up on it. So let's see here. What else do we want to do today? Okay, so let's see how much time we have. Okay. So I want to talk about a related concept, related to functions, something called scope. The idea is not complicated, but sometimes the rules for it are a little confusing. The idea of scope is this idea that if you have a variable and it stands for a value, that variable might only be able to be seen within certain blocks of code. So you might, have, you can think of like an analogy for this would be, different rooms in a house. And you might say, the variable, my favorite book is the orange one. And then within this room, look, I've got this orange book here, right? My favorite one, the variable, my favorite one, the orange one, right? But if I go to a different room, there might not be an orange one. There is actually no such thing as my favorite book. I want to do an example of that really quick. And we are going to go to JS Fiddle now. So if you want to go to JS Fiddle, just go to jsfiddle.net. And we're mostly going to be working within this section right here, where the JavaScript is. And you can pull up your results by looking in the console, because we're mostly going to be console.logging stuff. There is a way to just pop open the console here. If you're curious about it, you can look it up. How do I see console in JSFiddle? The steps are pretty simple, but I don't really like having that extra stuff there. But that's fine if you do it. Okay, so let's create a function. I want to make it pretty basic here. So function add 1, and we'll say input num. Well, actually, before we get to scope, let's talk about some good habits in terms of functions, and we'll do scope. So, let's see. Well, we could talk about this when we get to more complicated functions, but it's a really good idea to create a note anywhere where you have a definition of a function that gives an idea of how to use the function and kind of what it does. It helps to create this note even before you make the function, because it helps you work out what do you need your function to do, what are the inputs, what are the outputs. It gives you like the broad idea, what does the function do, but also you might go into detail and say my function does these particular steps. So we're going to talk more about planning and producing pseudocode next time we talk. But I want you to at least be thinking about, we would never go willy-nilly when we've got like some complicated function or some complicated module and just start trying to type it up directly in our programming language. Especially when we're juggling a ton of things in our head, we don't need to worry about the little curly brackets or the specific symbols we use or the specific little rules that this programming language has. If we're just worried about the abstract, the algorithm that we're going to use to solve the problem, it might help to just plan it out ahead of time in pseudocode, in this kind of fake code that doesn't have as many restrictions as actual programming languages. But for now, in terms of the good habits when defining our own functions, I think one of the best habits is naming things in a way that is self-documenting. That means I can just look at the names of the function and the inputs and get an idea of what the function does. So for example, if I name my function area, or what if I named my function calculate? That would be very poor for me to figure out what my function does, right? A better one would be area of right triangle, right? That would be great, because I can just look at the function, I know what it does, right? Especially if we're going to be calling the function in many places. If it's just called something vague, you're going to forget what it does. But if you're constantly being reminded, oh, this is what it does, that'd be great. Another convention that I really like is to actually describe what kinds of inputs and outputs in the name of the function. So when you call the function height and volume to blurple, the name of the function actually describes what the input is and what the output is. So you're going to have to balance, because obviously if you don't want to create a function name that's really long to type, so you're going to have to find some balance between being descriptive and having self-documenting code. So you could just look at it. You won't even have to look at the contents of it. You just be like, oh, I know how to use this because the name of it says, you know, radius to circumference, you know, radius to circle circumference or something like that, or radius to circle area or something like that. So you're going to have to find some balance between being descriptive in how you name things, but also not typing out, you know, a whole sentence every time you're just trying to execute, you know, just trying to call some function. So I'm going to leave that to you guys to figure out on your own, but this is another one of those tips besides just tinker with it that I can't believe how important it ended up being, that how you name things. I've made some mention of it before, but how you name things is going to basically expand how much stuff you can hold in your head, because you don't need to worry about thinking about what does this function do if it's in the name. You could hold other stuff in your head, basically. Okay. So for now, for our good habits, just think about how you name it. Make it descriptive. Make it, you know, descriptive enough that you can look at it and know what it does. And then later on, we're going to talk about how to document when you define these things to make your life easier in the long run, and also to solve these problems before you try to code them. But now I want to talk about scope, that idea of the rooms. So I'm going to go to JS Fiddle, and I like to indent anywhere where there's something that belongs to something else. So the lines of this function, I'm going to indent. So I have function, the keyword function, the name of the function is add1, the name of my input is also descriptive, input num. So I'm going to return, let's do this. Add1, add 4. We'll do add 4 instead. So I'm going to return input num. Well, actually, I'm sorry. Let's create a little local variable called to be added and set it to 4. And then we're going to return input num plus to be added. Okay, then I'm going to have another function. Well, first, let's do this. I want to just test this function out. So I'm going to console.log to produce output. I'm going to do add 4. And why don't we try plugging in 2? So if we add 2 to 4, we should have 6, right? So I'm going to get my console up. I'm going to run it. Okay, 6. I forgot to mention this. If you get this issue, console was cleared, you just go into your settings, and down here where it says clear console on run, you could just unflip that. Okay. So we got 6, right? Now, I want to try this out. Console, instead of add 4, how about we do console.log. What happens if I do to be added? And I run this. To be added. So you're going to see some error codes as, I mean, this is going to be a lot of what we do when we're programming, is interpreting these error codes. And the nice thing is that there's not an infinite number of them. There's a small set of error codes, and you become very, very familiar with them. This one says that to be added is not defined. So that's pretty clear. It means that whatever to be added is not defined. But I thought that we defined it here. We said that it's 4. This is an illustration of scope and the fact that this variable is called a local variable. That means it exists only within this block of code, only within the add 4 when we're executing add 4. So this seems like a bad thing So like, why shouldn't we just have all variables be able to be seen everywhere? But it's actually a really good thing. So we want to keep our information compartmentalized and separate. That way, they don't mix each other up. We should be in charge of whether our variables can talk to each other or not. And we shouldn't have as a base assumption that everything can interfere with everything. It all becomes a big jumbly mess if we don't have this kind of compartmentalization of everything. And this highly relates to modularity and this idea of a black box, that we should have the fewest moving parts. In this case, all we need to know about is input num, and all we need to get from it is the output value. We don't have to deal with any of this stuff in the middle. So this is totally abstraction, something called encapsulation. So where we 100% don't need to know. In fact, we don't want to ever change this to be added value. We should have nothing that should change it. It would break our add for function if this to be added value could be interfered with by other things. So this illustrates this idea of scope, that we may have variables that only can be seen within certain parts of your code. Okay, so that's the idea of scope. Let's do another really fun one. So we learned about functions, and we're going to talk a lot about functions. But now let's talk about how we can have some decision making built into our programs. And say we have some instructions that maybe we want to run it in some situations, maybe we want to run something else in other situations. So I'm going to introduce you guys to conditional statements. Let's see here. So now that you're familiar with the syntax, I didn't really talk about the word syntax, but we have these different components like functions and conditional statements and loops. Those are the concepts, those are the pieces, right? The syntax would be the particular way in a language, the symbols you use if we want to represent those things. And you could think of syntax kind of like the grammar of a language. English has a syntax. We have some rules about the symbols we use and, like the order of things that we have to follow in order to even make sense of what we're saying. So English, for example, every sentence starts with a capital letter. It needs to end with some punctuation mark, some terminating character like a period or exclamation point. When we have many items in a row that we're listing, we have commas. So all of these are the syntax rules of English. We're talking about JavaScript, the syntax for JavaScript. When we're defining a function, we would have those curly brackets that distinguish the beginning and the end of the body of the function, the steps that we want to do. We're going to have some parentheses when we're describing the parameters, the inputs of the function. So syntax is a concept that we should be familiar with, that the rules of the way we express things, the particular symbols we use that allow us to break things into pieces is the syntax. And going back to that idea that our problem solving is the hard part, and then figuring out how to take that problem and solve it in a particular language is not that bad. That's usually just a matter of learning the correct syntax of a different language. So syntax, we're going to see that there's two big kinds of errors that we make when we're programming. So one of them is a syntax error. That means you just mixed up on some symbol somewhere. You forgot your curly bracket. You didn't add a comma when you were supposed to. You said the keyword function, but then you didn't do like the inputs. Those are actually the easy errors, the syntax errors. Then the other kind of error is called logic error. And that's when we didn't break the rules of how to express things, but whatever it is we're trying to produce, we're not telling the computer to do the thing we think we're telling it to do. So, doing things, those are much more difficult to catch. So now that you know the syntax for functions, where we have, the top of the function when we're defining a function, we have the keyword function, then we have the name of it, then we have those curly brackets to designate the beginning and end of what steps our function does. The syntax for conditional statements is actually pretty easy. In fact, it's very similar for functions, conditional statements, and loops. So first let's talk a little bit about what a conditional statement is. So if we want to execute some lines of code, if we want to run some lines of code only if something is true, so on the basis of some condition, we would use a conditional statement. And so conditional statements have a couple basic parts. They use the keyword if instead of the keyword function. They have a condition that we want to check, which it has to be either true or false. And then it has some code that we want to execute surrounded by curly brackets. So it's going to look, if you remember that the our function definition has something like this, right? So this is the syntax for a basic if, for sort of basic conditional statement. The keyword if, in parentheses, we don't have our inputs, we have a condition that we want to check. Okay, so this has to be something that evaluates to a true or false. And then finally we have some curly brackets and some lines of code we want to run if the condition is true. So why don't we test this out really quick. I'm going to go back over here. Make this a little. Hopefully we can see this a little better now. And I don't think we need this. Okay. So here, let's make a variable, and we'll call it age, and we'll say, well, why don't we go back to that no teenagers allowed example. So we'll say our age is 14. I want to make a message pop up, but only if you're not a teenager. How about we do one just to make it easy? We'll make one if you are a teenager. So we can do something like this. If and I have some parentheses, in here I need to plug in a Boolean. So it has to be something that's going to evaluate to a Boolean. Like the most simple one would be if I actually put a literal Boolean, not a variable, not something that needs to be calculated, just literally true. Let's do this. If age is greater than 13 and age is less than 18, then I'm going to indent. Here, I'll use the alert pop-up just to make it really crystal clear, but again, if we have too many pop-ups, it's going to be bad. It might be good to just do console.log. Let's do alert. I'll do console.log. Console.log, oops, greater than 12 and less than 19, because we want to include 18. Console.log, you are a teenager. And let's run it. Okay, it said you are a teenager. Let's do an even more simple example real quick. So let's say let age equal 19. Let's see if you're an adult or not. And that rule is pretty simple. It's not a window like a restricted. All you have to do is be older than 18, right? Or you have to be older than 17. So if age is greater than 17, then we can console.log. You are an adult. It looks like I have some curly brackets, some of these things for some reason. Okay. So our first step, we declare a variable called age. We set it to 19. If our age is greater than 17, then we console.log, you're an adult. And if you look over here in the console when I run it, it says you're an adult. Now let's see what happens if I make it 12 and I run it again, I get no result. This doesn't seem like much, but it's super powerful. We can do things like check multiple conditions. Here we could have ands. We could say if your age is greater than this and your name starts with this. Another thing that we can do is have some nested loops. So let's say we want to give out some, some unsolicited health advice. So first we're going to check to see if the person is an adult. I don't know what the legal age to smoke is, but we're going to do this. We're going to say if the person's old enough to buy cigarettes, then we're going to check to see if they smoke. And if they do, then we're going to give them a message. And we can do this with nested conditional statements, meaning that we check some condition only if some other condition was met. So, I don't know what the age is to buy cigarettes. I'm glad I don't know. Smoking is terrible. I won't hold back about it. I smoked for a while and it was super hard to quit. Don't ever start. So, let's see. I think it's 21 now. So, if your age is greater than 21, then we can check a different condition. So, if age is greater than 21, and then we can say smokes is true. So we'll start at the top. We'll make another variable called smokes, and we'll set it to false. Okay, I'm going to double indent this one so we can really see that the outer if has these curly brackets, the least leftmost curly brackets, right? Then the inner curly brackets only pertain to this condition, smokes double equals true. So if it's true that the user is greater than 21, then we'll ask them then we'll check if they smoke. And here we can console.log. Please stop for your health. Okay, let's try this out. So right now, the age is 12. So it would not even bypass that first condition. So if the age is 12, if age is greater than 21, let's substitute age in here. So 12 greater than 21, that would evaluate to false. It shouldn't do anything, right? So let's try it out. If I run it, I get no result over here. Okay, so let's see. Let's say the age is 22. So then 22 greater than 21, this should be true. So then it should go to this next condition that we're checking, in this nested conditional, and it'll check smokes is false, so we'll do false double equals true. Again, this would be false. So only if our condition evaluates to true do we even do any of the steps inside here. Let's see here. Nothing. And let's see. Now, what happens if we make smokes true? Okay. So now this one was true and this one was true. So some of you some of you might be wondering why we didn't just put this condition in here and use an and. The reason being that we can set up what happens if, well, why don't I just show you? So we set up something to happen if our age is greater than 21. What happens is we run everything from this curly bracket to this curly bracket. Everything inside here only runs if this condition, age greater than 21, ends up being true. We can also set what happens if it's not true. So where there's the keyword if, on the same level, I'm going to use the keyword else. And in this case, now notice we have two ifs. This else has to do if one of our conditions is false. And it is dictated by these curly brackets. Notice this whole if has began and ended. So this else has to do with the first if. If you look at these curly brackets, this is the whole if here. Because this else happened after this curly bracket, then this else has to do with that first if and not the innermost one. So if it's true that age is greater than 21, we're going to do all this stuff inside here, from here to here. If it's not true that our age is greater than 21, we can run everything from here to here. So our message here could be console.log enjoy your youth, because we're speaking to someone who is 21 or younger. So let's test this out. If I run this, let's see, age is greater than 21. Oh, do I have to save it again? Age is 22, let smokes equals true. If age is greater than 21, do this stuff. Otherwise, if age is not greater than 21, well, 22 is greater than 21. What's the mistake here? Maybe I need to save it. Okay, let's run it. Please stop for your health. Age is 22. If age greater than 21, else, that's what I log. Something is messing up here. Smokes is true, age greater than 21, console.log. Please stop for your health. If age is greater than 21. Oh, my mistake, of course. Let's say our age is not greater than 21. Let's say our age is not greater. It is actually working perfectly. This illustrates a great point. A lot of the time you're going to think something is wrong with JavaScript or something is wrong with the programming language. 99.99999% of the time, you're just telling it to do something and you don't realize that you put in the wrong input. Then there's this phrase, garbage in, garbage out. If you put in bad input, you're going to get bad output. So this is a great example that illustrates that. I'm not afraid to show this either, because this is a never-ending struggle. You're going to be like, oh man, something's not working. That JavaScript or that Python or something. No, it's almost definitely you. So, okay, of course, it was going inside here because 22 is greater than 21. So that's why it kept going into here. Okay. Now if I run this, now it says enjoy your youth, because we're going to check that first condition here, age greater than 21. Now I've set age to 12. So we're substituting in 12 for age. 12 greater than 21 is false. So we skip everything from this curly bracket to this curly bracket, and we go to the else. That's why we got here. Okay. So let's say we want to make conditions for all four possibilities. So either the person is older than 21 or they're not, and also either the person smokes or they don't. That's why I didn't have one catch-all condition here, because we wouldn't have the fine-tuning to say, well, they were older than 21, but they weren't smoking, so we should have a different outcome. So let's make a situation where they are older than 21, but they're not a smoker. So I'm going to add an else here. And notice that it's the same indentation level as this if. And it helps me keep track that these two things are associated, this else and this if. And this else will trigger if this if was false. So let's say the person is older than 21, but they don't smoke. Console.log, you never started, good for you. And let's see. So they are older than 21, so we'll say 22. And we'll say that they didn't smoke. If I run this, you never started, good for you. Now, let's make the fourth condition. So we have either they're older than 21 or they're not. Either they smoked or they didn't smoke. So if older than 21, yeah. This checks if they're older than 21. If they're not older than 21, then we're not going to ask them if they smoke or they didn't smoke. We'll just assume that they're following the law. So this way that we could create very, very specific forks for every one of the possibilities that we want to account for. I'd like for you guys to create a password checking program. So we'll say let username, we'll call it uname, equals something, test, let pword equals test. And so the goal would be for you guys to take in a username or password. If the username is wrong, give an error that says username is wrong. If the password is wrong, give an error that says the password is wrong. But don't check the password if the username is wrong. So if the username is wrong, don't even check the password. So that should be the first thing we check, is the username. And then if the username is right, but the password is wrong, give a different error than if the username was incorrect. And see if you can figure out how to do that. And then you can plug in, once you've typed it up, so you're going to have some nested conditionals right here. Once you've typed it up, you can change these values here. You know, put in hairdo or whatever you want. You're gonna specify what the actual right username and password is. So you know, we're gonna have a comparison again. If somewhere we're gonna say if pword is whatever you want, but I want you to try to figure it out on your own. And we should have some different outcomes. So console.log if the username and password is correct. Console.log if the username is not correct. Console.log if the username is correct but the password is wrong. So those are the three outcomes I want you to account for. All right, so we did conditional statements. Let's see how much time we have. We're almost out of time. This is actually probably a pretty good moment to call it for now. Again, tinker around with it, play around with it. Of note, something that might be interesting to explore if you have a moment is to look at how JavaScript handles mixing and matching types. So for example, if I have the number 7, what happens if I add the string 7? Oh, that's pretty weird. I get a string 77, so you can look into that. Another big thing that I feel is going to come up, and I want you to be aware of, is this. Console.log hello world. Okay. Take a look at this code right here. I want to just display the message, hello world, right? There's a problem though. The problem is this. Anytime JavaScript encounters some words that don't have quote marks around them, it counts them as a variable and thinks that they stand for something else. It counts them as either a variable or a function, something like that. Basically something user defined. So let's just try hello. I don't want to make it complicated. So I want to display HELLO on the screen. And if I run it, uncaught reference error. Hello is not defined. So because we don't have quotes around the text, it thinks it's a variable. Now, we could solve this by making a variable called hello and setting it to this var stands for something. It does stand for something. So now we've defined what this variable named hello stands for. So if I run it, I'm going to console.log, we could substitute in that value, var stands for something. So this is probably something that it's going to take a little practice to get used to, but one thing that helps is running line by line, step by step, and every time you encounter a word, asking yourself, what does this stand for? And the simple rule is that if it has quotes around it, it stands for itself. It doesn't need to be defined, right? So if I did quotes around it, we actually literally mean HELLO. And I get hello down there. So we'll talk a little bit more about this later, but follow through these videos, and I will see you soon. I hope you have some fun. I'm sure you're going to have a lot of questions. Don't worry about that. Take it upon yourself to ask your classmates. You can always send me emails. It might take me a little while to get to you just this week, but outside of this week, I'll always be available for that. But I hope you have a lot of fun with this. I hope that you have some of your beginning. It's starting to dawn on you how all this stuff comes together, and really, we're thinking about this like a toolkit. All of this stuff can be used to build all kinds of different things. So there's no real end goal here. It's more I want you to have a skill that you can use in a lot of different ways. So I hope you enjoy this, and I'll see you soon.